we will simulate in this tutorial a very basic kind of plasmonic waveguide, 2D plasmonic waveguide. We will actually simulate a cross section of a waveguide. For instance, this is your waveguide cross section. This is insulator. This is metal. Let's take this metal. I name it M, and this is as I. And we are going to simulate this waveguide. For instance, if we extend it in this direction. So we are going to see the modes at this cross section of the waveguide, this basic metal insulator waveguide. Let us consider first that this waveguide is also infinite in this direction and in this direction as well. So what we will do, we will kind of simulate this waveguide semi-infinite in these directions and infinite in these directions, and we will try to look at the mode which propagate at this interface, since plasmonic are the surface waves and propagate at the interface between the metal insulator interface. So we are going to observe the mode at this interface. The basic literature for this type of waveguide is Economo article. You can find it on Google, and basically the type of mode that this support is, if it's the interface, this one, and this one is insulator, and this one is metal. So the mode should look like this. So it actually decays very slowly in the insulator and decays very fast in the metal. So this would be the kind of structure we will be simulating in this tutorial. It's really basic type of structure, and what you guys want to do is after this simulation is to basically simulate a 3-layer structure. Let it be metal, insulator metal, or insulator metal insulator. For instance, this is your 3 so this one is region 1, this one is region 2, this one is region 3. So this 1 and 3 should be of the same material. You can make it metal insulator metal or insulator metal insulator, and you can simulate at the end of this tutorial. You'll be able to simulate the cross section of this waveguide and look at the mode. How does it look like, what is the propagation constant, what is the attenuation constant, and I want you to compare it with the previous results in the literature. So that would be your homework.